Welcome to episode 10, where we're going to be adding function parameters and arguments to our function callings for user-defined functions. And soon enough, our built-in functions. But for right now, this is what we're going to be compiling and running today. It's just pretty similar to the last episode, except we're going to return an add, our calling of our add function. And it's going to take in two parameters that are integers, and we'll declare their types as well when we declare the function. And it's going to return an integer, and it's going to return a plus b. That's it. The first thing we're going to do is we're going to have to add a new token, which is our comma. So we'll go to token.py. So once we're in token.py, we'll go down to, we'll say right by the colon, do comma equals comma. And that's all we'll do for token. So we'll go move on into our Lexer now. We're going to scroll down and add the comma to our next token function. So add a new case, self.new token, token type dot comma, and just the current character. So that's it for the Lexer, pretty easy. We'll move on into the AST. Now for the AST, we're going to add a new kind of a special like helper node. We'll just make a new section down here, helper. So we're just going to call them function parameter node. We'll implement this right underneath the program class. So we'll add a new region, helpers, and region. The only reason I'm putting the function parameter node here is so we can use the typing IntelliSense down in the function after we modify this. So just for the sake of time, I'll copy and paste this. Function parameter is just going to take in a string name and a value type string. So that is just the a and then the int. That's all it's going to take in. And then same as everything else, the type and the JSON functions. Now that we have this node implemented, we'll scroll down to function statement. We're going to change the type of this parameters function to a list of function parameters, just for typing's sake. And we're going to start off with our parser. We're going to import our function parameter node. So from AST import function parameter. Just going to add another line here just for the helper nodes as we create them. We need to go to our parse function statement node. So I'll take our parse function statement function. Down here in the statement.parameters, we'll get rid of this expect peak. We'll get rid of this to do. And we're going to set this equal to self.__ parse function parameters. It's going to be a new function we'll create. So we'll create that right below this function just for ease of use. So we'll paste that in. Self will be a list of our function parameter node. Go ahead and get a variable for that. Function parameter equals empty list. First thing we're going to check is if the next token is a right parentheses. If so, that means we don't have any parameters, so we'll just return back our empty list. So if self.__ peak token is token type dot right parentheses. If it is, we'll go ahead and advance to that right parentheses, and then we will return back our empty list of params. If it's not, we're going to skip over our left parentheses by calling our next token function. We're going to get the first parameter. We're going to initialize that class. The name is going to be our self.currentToken.literal. We're going to expect a colon. So if it's not a colon, if not, expect peak token type.colon. And return none. Make sure we have an error out for that. We're going to skip over that colon with our next token function. We're going to set our first parameter's type. So first param.value type. It's going to be equal to the current token's literal. So that's going to be this int right here. Now we're going to append this function parameter to our params variable. So append first param. Now we're going to loop through and get all the rest of the parameters that were passed into this function, or declared with this function. So while self dot underscore underscore peak token is token type dot comma. So while the next token is always a comma, so there's still more to parse, we're going to call the next token function twice to skip over the comma and advance to our next parameter. So param function parameter, make a new class, self.currentToken.literal. So we'll grab this colon, expect peak colon again, and we'll paste it in here. So the next one should be a colon. If it's not, we want to head out. If it is a colon, we're going to skip over it because we don't care about it. We're going to set our value type, our parameters type, to the current token.literal. And we're going to append the new param to our list. So after that, we're going to expect there to be, once the next token is not a comma in this while loop, this will end. And then we're expecting a right parentheses. So expect peak token type dot right paren. If it's not, we'll return none. We'll return our errors. At the very end of this, we'll return back all of our parsed parameters. So that is a pretty big function, but all it's doing is going, starting at this left parenthesis, parsing each function parameter node until it hits the right parentheses. And it's going to error, and it's going to return back and allow us to keep parsing our function. Now we need to move on to our expressions. So when these are being called, so our call expressions, when we have our parameters or arguments being passed into that. So we can scroll down to our parse call expression function down here. So this is where we left that to do. Now we're going to get rid of this if not all the way up here to the expression.arguments equals. We're going to call a new function called self underscore parse expression list. This will be a token type dot right parentheses. That is the token we're looking for to end our expression list pretty much. This will get reused later down the line for other things. Unlike our parse function parameters, which is kind of centralized to our functions only. So we'll implement this function right below call expression. So we'll take in our self, in our end token, so that'll be our end token type. We'll return back a list of any type of expression node. First thing, we'll go ahead and declare our list of expressions. We'll set that to an equal list, or a empty list. We'll go ahead and check if the peak token or the next token is our end token type, or in our case right now, our right parentheses, which means we don't have any arguments to parse over. So we're going to skip over our left parentheses with our next token, and then we'll return back our empty list. We're going to hit our next token as well to skip over our left parentheses if we do in fact have some arguments to parse. We're going to go ahead and append to our elist dot append self dot parse expression. We're going to do our precedence type of p lowest. Now we'll do our while loop again, similar to our function parameters. Self dot underscore underscore peak token is. So while we still see commas, so there's still more arguments to parse, we'll add two more next tokens, skip over our unwanted tokens, and then we will append to our expression list our parse expression precedence type.p lowest. And I'll keep doing that until we run out of commas. Once we run out of commas, we want to make sure that our next token is our ending token. If not, something's wrong with our syntax or our grammar, so we need to return back none and throw our error in this function. At the very end, where we return our elist of expressions. So now that that's out of the way, we can go to main.py. We can set our compiler and run code to false, set our parser debug to true. We'll go ahead and run our file. We got a bunch of compile errors, but that's fine. We're interested in our AST, so we'll go to ast.json, and I'll get the lime file on the side. So with these, we have our add function, of course. We have parameters. This is where our function parameters are getting parsed, so they look correct. Our body looks fine. We'll go to our main. To our return statement, we're returning a call expression, calling the add function, and the arguments of that add function are just our integer of 1 and integer of 2. So that's parsing correctly. So we can get out of here and move into our compiler. First thing we'll do is import our function parameter from our AST. We're going to first fix a couple things in our visit function statement. So it's on line 114, visit function statement. This will not be identifier literals anymore. This will be a function parameter list. And now that this is our function parameter, this will not be a p.value. This will p.name. So that's just gonna, that fixes everything to use our new function parameter node instead of our identifier literal nodes. Now we have param types. We can get rid of this to-do flag. So self.type map p.value type for p in params. So this is just going to get the LLVM type for each of our parameter types and put them into a list. Now scrolling a little bit down underneath where we set our previous builder and set our new builder for the function, we need to do a couple of things, such as the first thing will be storing the pointers to each parameter. So we need to allocate all of the memory for our parameters in the function. So we'll have a params pointer list for I and then a type. And we'll use our enumerate function so we can get the index out of it, which is where I comes out. We'll enumerate through our param types, which as we can see up here is just our LLVM type mappings. In our for loop, we'll set a variable pointer equal to self.builder.allocate the LLVM type. We will store it now, so self.builder.store our function.args at the index that we're looking at in param types. And we'll store it at that pointer. And then we will append this pointer to the list above. Next thing we'll do is add all of the parameters to our environment. So we will adding the parameters to the environment. So previous CNV, self.env here, and then underneath the as we set our new function environment, we're going to do for I, comma x, and enumerate. We're going to use a couple Pythonic things. We're going to zip the param types list with the param names list. So it's just kind of combining them together, zipping them together, so we can loop through them both at the same time. we're going to set a type variable to the param types I. We're going to grab the pointer from params pointer I, and then we're going to define that in our environment. So the x1 tuple will be the pointer and the type. So we're defining that parameter in our environment, or each parameter in our environment. Then we're moving on to the rest of our code where we define the function, compile it, and then set everything back to normal after it's been compiled. Last thing we need to do is go to our call expression function, so visit call expression. First thing is we need to fix this. This is going to return a tuple of ir.instruction, if I can spell, and ir.type. So we have our name and our parameters, and here's our args and types empty list. So we'll get rid of this to do. If the length of parameters, or params, is greater than 0, so if there are parameters to go through, or args, for x in params, we are going to grab the parameter value and the parameter type from our resolve value function. So we're going to resolve x, or our parameter's value. We're going to append to our arguments this value. Then we're going to append to our types this type. And that is absolutely it for resolving these variables for our functions. So we're going to call this function from our environment by that name. And we're going to pass in the args that we just set up here. And that's going to go through the rest of the function for the call expression. And this should be it to go into our main.py file again. We'll set parser to false. We'll set compiler to true. Go ahead and run that. And it looks like we are getting some type of an error. So let's look through this.
3 hours later.
Okay, the error here was a little weird. So in our visit function statement, in where we set our previous environment, we set the parent to our previous environment variable, and then in here xi needs to actually be x1 since x is a tuple, so we want the first index of that tuple, so x1 not xi. And then we run that, there should be no errors. We'll investigate our IR code. So in our main function, we are calling the add function with the 1 and 2 as the arguments. And then we return back whatever the result is. In our add, we're storing these two parameters. We're allocating our types, then we're loading them, and then adding them together and returning them back. And that's so everything's looking pretty good here. We can go into main.py and set run code to true, save that, and then program return 3. Now we can add 50 plus 50. Should be 100. Cool. We can go ahead and add a new function, be int, and we can pause a minus b. I'll just put a semicolon for fun. So we'll add this to make that sub 50/50, which equals 0. Now, I don't know how negative is going to hold, but let's see. Oh, wait, hold on. That's dumb. So 50 and then 20 here. Will this give us negative 30 by chance? Okay, yeah. We don't have negative numbers implemented yet, but hey, we sure can get them. But yeah, alright. So that is adding parameters to our functions. So you can now call functions with any amount of parameters. We'll see you guys in episode 11, where we're going to tackle adding strings to our language and finally the printf function.